Hey everybody, today we're going to talk about how to do a air pressure reset in CCT. Now normally this is done at a supervisory level, like in LCT if it's in an NAE, or if it's in a JACE, it's done in Niagara programming, but it can be done in CCT, especially with peer-to-peer. You can peer-to-peer your VAV boxes back to the air handler controller and do it based off a damper. So let's look at the sequence here that someone sent in and see if we can do this inside of CCT. So this is a static pressure, duct static pressure reset control. And we're going to look at the damper position of all the VAV boxes. And if the dampers are below, all the dampers are below 60, we're going to reset it down at a rate of 0.1 inches of water column. If any of the VAB boxes or any are above 90, we're going to reset up at a rate of 0.25 inches. So if they're in between this, we're not going to do anything at all. So do that. We're going to look continuously at it, but we're going to limit the reset frequency to no more once every 15 minutes. And of course, we're going to have minimums and maximum set by tab. All right, so let's look and see if we can do this. Sure we can. We're going to come in here and do a new program. And I'm just going to choose the standard minus the economizer. Don't need that extra logic, but as long as we got variable speed in here, that'll throw the discharge air pressure and supply fan speed in the programming for us. There is the 2/3 sensor, and here is the supply fan output. So we know we have that. Now we do have this air set point determination, but if we look at the logic on that, we're just resetting it based off of warm up or cool down pass through. We don't care about that. We want to add static pressure in. So to do that, we're going to create a new activity. I got my duct static reset. We're going to view the logic on this guy and throw in what we think we need. So floats, I'm going to start with the minimum duct static pressure. So min pressure, remember that's set by tab. I'm going to go ahead and say they're going to let us go all the way down to 0.25. That's probably not the case. It's probably going to be a minimum of 0.5, but I'm just going to go ahead and do 0.25 just for the sake of it. I'm going to duplicate. We're going to need a max pressure. And for this, I'm going to allow it to go up to 1.75. Apply. All right. We're also going to need our damper position. So I'm going to throw in 3. Obviously, you have to add however many dampers, how many VAVs you have under this air handler that you want to look at duct static reset for. But I'm just going to do 3 just for now to see if it works. There we go. All right. I'm also going to throw in, and even though it didn't say it, but I'm going to throw in the delay time because I've often had this change in the past. So And for testing purposes, I'm going to put this at 15 seconds. All right. Now you could make the next couple input floats, but I'm going to go ahead and make them constants. And the first constants is I'm going to do what we're going to reset down, and that's going to be 0.1 inches. So I'm going to label it 0.1 inch. I'm going to put 0.1 over here. And then I'm going to bring out our reset up, which was 0.25 inches. And over here, 0.25. Okay. Now we'll bring in constants for the programming here. They said 60%. If they're all at 60, then we can reset down. If any one is above 90, we're going to reset up. In between those, we're not going to do anything. All right. I think that's all I need for my inputs. Now, let's work on this one at a time. Max. So it said all of them had to be above 60%. So if I take the max, or below 60% open. So if I take the max, that'll be the highest number. And if this is under 60, then we're good. Or above 60, should I say. So I am going to, or under 60. View details. Add. And then close. That'll give me 3. So this is going to be my reset down. I know I'll need another one of these for my reset up. And that's going to be this guy. Okay, I'm going to go ahead and hide these to make the lines better. There we go. So let's look at my reset down here. So I'm going to look at a less than. So if my max is less than this, I'll go ahead and hide this as well. And I have to have a timer in here. And I got to expose a few points for my timer. So I'm going to expose the reset and the duration. I'm going to go ahead and set it up for a on delay. I don't care about this because I exposed that point, so whatever is there is going to take over. Apply. And then I'm going to bring this timer output and put it right back into here. Now I want the timer to keep resetting itself. And if I pull out of here, it won't let me hit that reset. So what I'm going to have to do is add a last value block in here. And that's going to be a Boolean coming out of that timer. And I'll run it through here and around there. Okay. So now that'll just continue to reset itself. And I'll get that. Now I can bring in my mux block, and it's going to be in Boolean mode with a floating IO. It's Boolean because it's coming out of this AND, right? And so this is going to be here. Remember, this is my reset down. So what do we want it to do? This is going to come over here to 2. Hide this. So reset down. Anytime this is true, we're going to hit 2. And that's going to be that 0.1. Anytime it's false, it's going to hit this, which is 0. Just for friends, I'm going to change that false. That way it's very clear what it's doing. That. All right. Now I need to subtract that from the set point. I'm going to stop here. And now I'm going to work on the other side. So what if any of these are open above 90? So any, we're going to do a max again. If they're open above 90, so I need a greater than. Put this down a little bit. So if this is greater than this, then what do we want it to do? We need an AND again. So I'm going to duplicate this. We actually accidentally still had this one highlighted, so I'm going to delete that guy. So we got this and we got this time delay. So now we got to fire the time delay. So I'm going to do an OR block here. I'm going to take it out of this and, or this less than here. I'm going to take it out of this greater than here. And that's what's going to fire this on delay. We're going to reset ourselves. So now we need a mux block over here, float IO. So really the same thing. So if I can just duplicate this one, bring it down, I'm going to drive this to the mode side of things. And then we're going to do 0.25 inches. I'm going to put that in 2. I put it in 2 because I already know it's on default true to 2. So there we go. And now we need to add that to our set point. Okay. So this part I think we're good on. Now let's look at our set point here. We don't want to go below the min, and we don't want to go above the max. So what we need to do is add a max and min up here. There's a max, and I know I'm going to need a min. There's a min. Okay. So if I take the max of this and the min of this, and if I take the min of these two right here, I know we're getting to an output somewhere. Go ahead and grab my output float, throw it over here for the time being. Okay. So now we got to figure out if we're going to subtract or add, right? So to do that, the best way I can think to do that is do a command hierarchy block. And this time I'm going to go with an enum out because that'll give me 3 options. Set this guy up here. I'm going to get rid of this enum, and then I'm going to add in another boolean, okay? And I'm going to call one of these up and one of these down. And then I'm going to change this to a state that has 3. Off, on, hold sounds good to me. And now let's set this guy up. So up, if up is true, we don't care about down. We want it to, let's just say on. On is up, okay? I'm going to insert a row here. That way I don't get screwed up here. If up is false and down is true, we want it to go off, okay? And if down is true, if they're both false, we're going to go on hold. Makes sense? All right. So now I got an up, down. Remember, this was down. So if I go here, connect that to down, and if I come out of here and connect this to up, I know if I'm going up or down. Now, I need another mux block here. This time we're going to have an enum mode floating output. Change this enum to on, off, hold to match the other one. I have to put in a default. So I'm going to label these up, down. Put a default on 1 just so we can get it here. So now, also need one more input. There we go. And then this last one we'll call hold. Okay. So on up, what do we want it to do? Up, we said was on. Hold is hold. And down is off. Okay. There we go. Now we're tied into our mode here. This is up. This is down. So now we need to take this and run it through our max. Okay. Now we want to connect our min to our subtraction blocks. We're going to get this. We have a loop, no problem. We're just going to add in a last value block. And this is going to be a floating last value block. So now I connect the last value to the subtract and then to the add. And then finally, this guy is going to be our output. All right, I think that's good. You ready to test it? Let's see. Simulate, save changes. No, I might have to screw something up. All right, so they're all below. We should all be at 0. So they're all at the min. So our output right now is 0. Why is our output 0? Should not be 0. Should not be 0. We actually have to do the hold. I did not connect the hold. So let me configure. Stop simulation, yes. Take this last value one more place. It's going to go straight to the hold. There we go. So now when we simulate this, we should be where we need to be. Because we can never go to 0. We have to stay above our min set point. There we go, 0.3. That's a lot better. This is still at 15 seconds, yes. Did we connect that? No, we did not. So let me configure this again and connect the duration. There we go. Now, last time. Do this. All right, we can watch it, but it shouldn't go anywhere below 3, and it shouldn't because we're in a hold state. So let's start playing with our damper. So they all have to be above 60 to drop them, but if any one of them are below 60 to drop it, but if any one of them get above 90, it should increase. So let's go 91, and let's see if this increases. So it should increase at a 0.25. Okay, there we go. We went up to 5. And that's not really 5. I mean, here's the current value down here. Here's 8. Okay. 10. We can we can't change our precision here. 1.3, 1.5. Now we can't go above our max, remember? So let's see if we stop at 1.7, 1.75. 1.8, which is probably 1.75. We can't change our display precision here. So as long as it stops here, I think we're good. Looks like we're good to me. So let's start dropping this. At 61, we should hold. Anything below 61, remember we're taking the max here. So if we drop to 60, technically, it should start dropping. Let's see if we go anywhere from 60. Now this should drop slower because it's going to drop at a 0.1 inches. No, because we're doing a less than, so we need to go a little bit less than 60, 59. Now we're getting that true right here. So now let's see if it drops. 0.7, 0.6, 1.6. As that's doing this, which I can't really do anything right now with it. If we want it to go to 0, 1.3. Now again, we would have 15 minutes on here instead of 15 seconds, but for testing purposes, I believe this is working. Now we want it to hold. 0.9. Point 0.8. Let's see if it holds. So I'm going to go to 70 here, and this should hold it. We're currently at 0.8. Let's just wait a second and see if it drops or gains or anything like that. And it is not. So I believe the holding is working. So now, remember, because it stated all dampers had to be below 60% open. So if I change that back to 59, we should see it drop. Yep, there we go, 0.7. 0.6. Let's just make sure it doesn't go below our minimum threshold, which is 0.25, but this will probably display 0.3. Again, we can't change our precision here. There we go. It did not drop below. So I would say this works 100%. Thanks for watching.